Hello students, today we will learn about the installation and the debugging of the collection terminals and the meter reading. Introduction. The concentrator, special transformer terminal, acts as the terminal device for electricity information collection. It connects the upper and lower systems, undertaking the functions of the remote and the local communication channels. It is the most critical terminal collection device. Therefore, the functional specifications and on-site installation, wiring, and debugging of the concentrator are crucial and affect the success of electricity information collection. Today, we will cover 4 aspects: the basic knowledge of collection terminals, the installation and wiring of collection terminals, on-site installation and quality inspection, and on-site debugging of the collector terminals. Part 1. Basic knowledge of collection terminals. The concentrator collection terminal is a device that collects data from various collection terminals or electrometers, processes and stores it, and it can exchange data with the main station or handheld devices, hereinafter referred to as a concentrator. The concentrator or special transformer terminal is the core device in the centralized reading system. Concentrators and collectors are collectively referred to as collection terminals or centralized reading terminals. The collector is a device used to collect energy information from multiple electrometers and can exchange data with the concentrator, hereinafter referred to as the collector. The collector is used to collect energy information from multiple or single electrometers and can exchange data with the concentrator. Concentrator, collectively referred to as collection terminals or centralized reading terminals. The downstream communication channel of the collector supports RS-485, satisfying the load capacity for 12 to 16 electrometers. The upstream communication channel supports power line carrier communication. Concentrators are divided into cross-collection and non-cross-collection types by function. The upstream communication channel uses a wireless public network, while the downstream communication channel is a power line carrier. It is configured with one AC analog input and one RS-485 output interface. It mainly consists of an LCD screen, optical communication port, USB interface, remote communication module, and a local communication module. Concentrator status indicator, remote communication module status light, power light, modular power indicator light. Red. When the light is on, it indicates the module is powered. When the light is off, it indicates the module is off. Net light. Network status light. Green. 3TR light. Module data communication light. Red and green. When the red light flashes, it indicates the module is receiving data. When the green light flashes, it indicates the module is sending data. Carrier communication module status. Power light, modular power indicate light. Red. When the light is on. When the light is off, it indicates the modular is off. TR light, modular data communication light. Red and green. When the red light flashes, it indicates the modular is receiving data. When the green light flashes, it indicates the modular is sending data. A light. A phase send status light. Green. B light. B phase send status light. Green. C light. C space send status light. Green. Link light. Ethernet status light. Green. When Ethernet port is successfully connected, the link light is on. Data light. Ethernet data light. Red. When there is a data exchange on the Ethernet port, the data light flashes. Installation and wiring of collection terminals. Technical requirements. The main wiring of a concentrator requires using at least 2.5 mm hard copper wire, generally choosing 2.5 square millimeters or 4 square millimeters. 2 hard copper wire for connection. Since the concentrator uses power line carrier for downstream communication, Auxiliary terminals generally do not need to be connected. If encountering special circumstances, it is recommended to use signal lines for connection. Additionally, after the constrainer is installed, the antenna and the SIM card need to be installed, and upstream communication debugging needs to be performed. The concentrated wiring method is 3-phase 4-wire. To ensure normal carrier meter reading, the ABC 3-phase voltage and the neutral line must be connected and secured. Check if measurement point 1 voltage and current are normal. During installation, pay attention to card installation, secure, and antenna position. Signal strength meets communication requirements, 2 bars or more. After installation, the card wait 5 minutes and check the applied left constrainer icon for the appearance of an inverted triangle. On-site installation and quality inspection. Task description. Independently complete the wiring from the junction box to the electric meter and the constrainer. Site equipment tools and materials. Low voltage metering training cabinet. 3-phase 4-wire meter. Concentrator, combined junction box, antenna installed, multiple 485 connection wires, single core copper wire, 2.5 square millimeters, yellow, green, red wires, single core copper wire, 4 square millimeters, yellow, green, red wires, personal tools and provided on site, safety tools, assessment points and requirements, safety measures, work procedures, correct measurement, construction process, hazards and safety measures. Dress complies with the safety work regulations requirements. Correctly wear safety helmets, cotton gloves, long-sleeved work clothes, and insulated shoes. Verbal handling of work tickets. Set up fences as work site. Hand work here signs. Before work, complete 2 wires and 2 wires, and 3-step electricity testing. Concentrator electric meter installation and process quality. Appearance inspection. Check if the electric meter, concentrator, and combined junction box are intact, if the parameters are correct, and if the relevant parts are sealed. Wire selection for voltage and current. Current U phase to yellow wire, B phase to green wire, W phase to red wire. Ensure correct wire color selection. Select 2.5 square millimeters wire for voltage circuit, 4 square millimeters wire for current circuit. Ensure current wire diameter selection. Wiring process. Wiring process requirements. All connecting wires should be horizontal and vertical, reasonably crossed, aesthetic, and layered by color. Wiring from the combined junction box to the electric meter should follow clear layer process requirements. Wiring bending. Do not bend wires using metal pliers or scratch wires with wire scrapers. Wiring quality. Tighten the wiring terminals of the electric meter, junction box, and concentrator in order from inside out. Wire crimping regulations. Each wire crimp should have 2 points. Wire mantle should not be exposed. During the wiring process of a 3-phase 4-wire electric meter and the collection terminal, tail, meter, circuit terminals, pay attention to the wiring direction of each phase voltage and current to ensure current metering by the electric meter and correct wiring of the collection terminal. While selecting wires based on the choice on the wire's internal diameter, judging wire type by external diameter is inaccurate. Organize wires. Hold the wire within 2 fingers of your left hand from one end. Use 2 fingers of your right hand to straighten the wire from bottom to top 3 to 5 times. When bending wires, keep the thumbs and forefingers of both hands together to bend. 4-finger bending. Do not apply force with other fingers to avoid wire bending. First bend with the wire into an acute angle, then restore it to a right angle to ensure neat appearance. 485 wire and junction box installation. Ensure correct wiring while connecting the electric meter and concentrate with 485 wire. The screws of the voltage connection pieces in the junction box should be tightened without any looseness. The current connection pieces in the metering combined junction box should be tightened without any looseness, ensuring correct connection. On-site debugging of collection terminals. After installation, the collection terminal. Conduct on-site power-on debugging. Carefully observe the concentrator's display screen and the indicator lights of the remote communication modular and the carrier communication modular. Observe the concentrator's display screen to determine if the upstream channel G network or C network is connected. Check signal strength. Need to ensure remote the communication modular is functional normally, and the data line is fashioned alternately. Once remote communication is confirmed to be normal, observe the data reception line is carrier communication modular by reading data points. Finally, input the measurement point number, successfully read the electrometer data, and verify it against the on-site electrometer data to ensure consistency. Only after successful data collection at the main station can you leave the site. This concludes the installation of debugging of collection terminal equipment. Next, the students will be pursued to the practical training site to conduct a practical exercise according to group list.